Thank you for joining us today. Today, like just said, we will be going over the User Experience Insights, which used to be Cape Networks. So let's get started. So quickly, we'll run through an agenda. We're going to kind of talk about what User Experience Insights is, define the problem, how UXI solves the problem. Then we'll jump into the interface. I'm going to try and minimize the slides today. We'll go through a dashboard overview, look at the configuration for some tests, do a quick summary, and then jump into questions and a little happy hour if anyone wants to hang out and talk afterwards. So deploying and managing networks is challenging. The biggest thing is there are so many remote offices out there today without having an IT person on site today. So with that, we need to have tools out there that are able to monitor and test the environment without having manual intervention from a user. So that's where User Experience Insight comes in. It's a purpose-built sensor, very simple, very similar size to an access point. Kind of looks like an AP105 or a 205 for those Aruba people that are out there today. The great thing about these is they're very easy to set up. They're actually even easier to set up than an access point, which is very easy to set up in and of its own. So the great thing is it's a cloud-based UI. So there's nothing for you to deploy on site except for the sensor itself. The great thing is the sensor uses built-in cellular to communicate to the cloud for its first time. With that, it'll actually get its configuration that we configured in the cloud and start its monitoring and environmental monitoring for your site. So the great thing about it is it's a Linux-based client. So there's a lot of tools that we can actually add on to the sensor. And there are new pieces being added on today, even that we tried to get for today's demo, but we weren't able to get engineering to enable it quick enough. So we're actually able to look at wired and wireless. It has a cellular backup, like we were talking about. We configure everything through a browser, and it's actually even got a small little battery in it for it to actually be able to do graceful shutdowns when it loses power. So the great thing about it is we're actually able to go through and ensure user experiences. So the great thing is the sensor acts as if it were a client within your environment. It actually goes in, connects to an SSID, looks for AP association, checks your DHCP, your DNS. Then it actually starts to look at your RF environment as well, to look at your signal quality. It could actually log into captive portals, which is really cool. So you could validate that your ClearPath server is working and doing your guest captive portal correctly. Or if you're in a Cisco environment, your ICE guest captive portal is working properly. So then we're able to go in and take it a step further where we can actually look at authentication. I already mentioned DNS and DHCP. The great thing is we can actually do iPerf tests and validate that we have proper bandwidth and speeds across our environment. The great thing too is we can also look at reliability. We're able to look at things like MOS scores, jitter, latency, all of those typical things that you're looking at when you're looking at your health of your environment. So to exactly what I was just talking about, we're looking at throughput, latency, and jitter, and we have built-in tests to like things like Office 365, Salesforce, Dropbox. So we're easily able to go through and test those types of authentication and latency to make sure that those applications are readily available from each of our sites. So imagine you're a healthcare and you have 50 clinics. You're not going to have 50 engineers out there, and you don't always trust what a normal client is reporting back to you as up, down, performance issues. This is a great tool that you can put out there that you can trust, that'll allow you to know the reliability and the stability of your networks in remote locations. So the way that it really helps us is it's continuous automated testing and troubleshooting, easy to view and monitor what's going on. And there's actionable insights. It'll actually help us determine what's going on the network so we can easily go through, focus, fix, and validate that the issue is there, which gives everyone else on your team a peace of mind, making it very easy for us to go forward. So I'm going to show some of the basic tests that we are able to go through and look at. So I'm not going to read all these because there's a lot on here. And like I was saying, there's even more coming out. The great thing about the platform is it's very easy to write custom things to. So we're able to go in and create custom testing, which we'll show one of those here today. So I'm going to jump out of here and I'm going to bring over our dashboard. So let's jump into the dashboard. So you can see what we have here is a very simple, easy to view dashboard. So what I've done is I've created two groups. I created an internal and an external. And all that does is allow me to do different tests within each one of those different sensors. So you can see on the external sensor, I am only doing the typical services of Wi-Fi, Ethernet, DHCP, making sure I can get to my gateway and I have DNS connectivity. When I go to my internal group, you can see I'm actually doing some iPerf testing. I'm actually validating that my remote access point controller is reachable from inside the network. I can also test this from the outside one. So from a home network or anything, I can put this out there and validate that it's coming in that way. You can see I'm checking Slack. Slack's been having a lot of issues today. So I can click on that and see when we've been noticing Slack outages. And I can actually then click into here and actually expand of what's going on. And it's also telling me what network it was noticed that we were having issues with Slack. So you can see here we have the wireless Casa de Kohler and the wired network, which is also failing for Slack right now. So I'm gonna jump back in there real quick. And you can see it's looking at, gives me Slack Web API, how long it's taking for things to respond, gives me latency, amount of packet loss, jitter, and how long it's the website is taking to get an HTTP GET and respond back to us. So great information. You can even see down here at the bottom, we're doing a port 80 test, a 443, we're doing a ping, and we're actually doing a web API call over to it. So one of my favorite ones was the iPerf one. So I want to jump back over to that one. So this one's a nice, easy test. We are running an iPerf server just on a Windows box. And we have it set right now to 75 megabits of what it's trying to push through. You can see here, we're pushing anywhere from 71 to 72 megabits. So we're getting very good throughput over Wi-Fi. So it's great to see. In a second, I'll jump in and show you how we can adjust some of these settings and actually get more out of, or be able to test for higher speeds or different pieces that we can change. So you can just see very simply, we're going to internal IP address, we're doing an iPerf v3, and we're set up for 75 megabits. So I'm gonna click on this little guy here, which is gonna take me straight into the testing page. So you can see iPerf 3 here is set up, and I can just click on the little pencil button, very similar to most editing tools that you can notice. Pencil is always your edit tool. So what we're doing here is I'm doing an iPerf v3 test to this IP address. I am doing a download to make, so from the server, I am downloading to see how fast I can download. So I can create multiple tests where I can do downloads and uploads to validate throughput. And obviously when I'm doing that, I would have to create multiple servers with different ports on the server side. So just something to remember, you can only do one iPerf connection to a server on a single port. So if you want to have multiple iPerf tests, you'll need to create multiple instances with different ports available. So easily here, I can change this to 100 meg. Window size, it's auto sizing right now. So if I want to change my window size, I can determine how long I want to run the test for. So I can validate that I'm not just getting a burst of acceptable speed. I can test that for 30 seconds, I'm getting 100 megs of throughput. The number of streams, and then how often we want to test. So you can see these are very easy tests to set up. And I'm going to save that. And then once we're done going through a couple of these, I'll go back and take a look at the test to show that it's gone up to the 100 meg and see what we're getting on our throughput there. So you can see these are very simple to set up. So if I want to add a new test, so let me take one step back. You can see here, the tests that we're looking at are going across two groups and two sensors. So if I wanted to make one available just to a single sensor, I would actually, so like we were looking at the external sensor over wired and wireless, you can see that there's no test enabled. So if I want to, I can actually just click on this box here, enable a couple of these. Actually, let's turn that guy off. And now that sensor is going to start running all of these tests. And the reason that you want to do this, say you have a subnet that is not available. So for example, this iPerf is only available on my internal network. So that's why I don't have that enabled on my external group, because it doesn't have access to that subnet. So as I click out of there, close that, you'll now be able to go back and take a look at that and see that that's all set up. So very easily, I want to also show the setup for the networks. So you can see, very easy to add. We can go here, SSID, and this is actually going to show all the SSIDs that it's seeing. I would then click onto one. What it does is if you don't type in a name here for an alias, it will automatically use that SSID name as the alias, which is what shows up on the test page. I am then able to select if it's an open SSID, passphrase, or enterprise. So I'm going to show an enterprise setup. We are going to do eat peep, and we're going to do MS Chat V2. And you would just type in a service account is what I highly recommend here. I do not recommend using someone else's account, like your own personal account, because as it's going through, if it continues to authenticate and fail, it could lock your account or cause issues with access to your other applications. So I always recommend creating a service account for this. So you just type in Charlie, and, or since I said a service account, so let's do SVC-Charlie, and then I type in a password. Obviously, I don't have this set up right now to authenticate using this right there, but I'd hit add, and then it would start testing that right away with that. The very great thing about this as well is if you have a ETLS environment, you can actually upload a certificate here and be able to authenticate using that certificate. So you can actually validate that your ETLS is working properly. So you can see there's some extra settings in here. If you're running a proxy on your environment, you can actually have it determine auto or manual. You can set that proxy. So you can then validate that you're having that connectivity. So I'm going to discard out of this one, and we'll move over to the wired. So you can see the wired is very similar. You're going to give it a name. So you can give it a subnet name or whatever you want it to call. And again, if you're doing 802.1x on your wired side, you'd be able to set a username and password or certificate-based authentication. And again, there are some basic advanced settings here that you can go in and update as well. So we got about 10 minutes left, so we'll jump over to thresholds. The great thing about this is we're able to go in and actually set thresholds. So say on the wireless, you want to make sure that the sensors never saw less than -75 dBm. So I actually would change this. I would say I don't want to go below -68 for more than 5 minutes. So that will tell me if I know my coverage is always -68 across my environment, but if I lose for more than 5 minutes, that -68 or better, that means I've lost some access points, and I want to take a look at that. Granted, we're also going to get reporting that we have down access points through tools like Airwave and Central. So there are other ways to get notified, but this is great to tell us that how that affected the environment. So I'll save that. So there's lots of different ones that we can do here. So you can change bit rate. So if you have a low throughput for more than 5 minutes, a lot of times that's because we've got greater distance between ourselves and access points, or we're having ISP congestion, or just network congestion. Great things that we can look at. High rate or high reach rate. So that means that we have low signal quality or high signal to noise ratios in a lot of cases. So it's great things to see there. And again, that high channel utilization is a great one for us to see as well. So I'll click on the network thresholds. And obviously there's a medium one that's warning and a high one that is error. And you can actually enable which one you want and which one alerts you as well. So internal thresholds, this is where we look at latency, loss, jitter, and VoIP MOS. So if you have an internal VoIP server, Skype for Business, Cisco Unified Communication Server, and a Avaya PBX, any of those, we can point to those, monitor those, and make sure that we have good connectivity and good voice quality on that. So on external, the same stuff that we're looking at latency, loss, jitter, and across the different things that we looked at earlier today. So here you can see the sensors. You can change the name, which right now they default to the serial number. So the great thing would be to, just like you would an access point name, give it something that tells you the location. So I can say Costa de Kohler or Surevera main conference room. And that would tell me that this is the sensor in the main conference room. That way, when I get an alert, it'll tell me that the main conference room was having issues. So one of the things that you want to kind of take a look at is how many of these you want to deploy. The Aruba recommends anywhere from one sensor for every 5 to 10 access points. So about half as many as you would for an air monitor. These are able to go out and test wider areas. So some people will even only put one of these per building if they have a lot of remote sites. So it really depends on what you're trying to test and what your environment looks like, which will determine how many sensors you need. But that one for every 5 to 10 APs is a good starting point. But definitely want to talk through the design of that with one of your engineers.
Thank you for watching our webinar replay. We hope you found the information helpful. The Surevera team is ready to assist you with any follow-up questions or needs you may have. To get more information about our upcoming webinars, join our email list from our website or follow us on social media. You can also access all of our existing webinar content on our website and social media channels.